Today we are going to be talking about properties of logarithms, okay? Biggest thing, we're going to talk about expanding and condensing logarithms. Go ahead and write that. Expanding.
Where do we write it?
On the front page of your notes anywhere. Expanding and condensing logarithms. What does it mean to expand something? Okay, what does it mean to condense something? Exactly, okay? So, I'm going to give you some properties here. So, the first one, I have log, I'm just going to call base x right now. Log base x of AB. Okay. Right now, that is condensed because we have one log. Okay. To expand, we're going to turn it into more than one log. Right here, what's happening between the A and the B? Operation. Multiply, add, subtract, divide. They're multiplying together, okay? So when we rewrite this, we are going to have a log go to both of these. So I'm going to rewrite log base x of A. When they're multiplying, when we expand it, we are going to be adding them together. So plus, and then the other one is log base x of B. Okay. So from here to here, we are expanding. What if I started here and went to here? That would be condensing, right? So what I want you to understand, multiplication goes with addition. Okay. Let's write that off to the side. Multiplication. I'm going to write a two-way arrow here. So that means both directions. Addition. So if you started with multiplication, you go to addition. If you start with addition, you go to multiplication.
So does division go with subtraction?
Was the what?
Does division go with
Yes, yep. Number 2 is when we have log base x, and now I'm going to go A over B. What's happening between A and B now?
division?
They're dividing. So what do you think goes with division?
Subtraction.
Subtraction, exactly. So that's in condensed form right now. Again, how do I know that this right here is condensed? Because we only have one log. Yep. So if I expand this turns into log base x of the numerator, A, and then division turns to subtraction. So this is going to be minus log base x of B. Biggest thing with division is make sure when you turn it into subtraction, it's numerator minus denominator. Okay. So again, this goes division goes with subtraction. Okay. And then there's one more to talk about, and that is when we have an exponent involved. So if I have log base x, this time I'm going to go a to the b power. What is the b right now in what I just wrote?
Square. No.
It's an exponent, right? That b right now is an exponent. What's kind of cool with these, what happens to that exponent when we rewrite this or expand, okay, it is going to turn into coming to the front. That exponent moves to the front of the log. So this turns into b times log of x a. Okay, so when you have an exponent, that just moves to the front of that log. Okay. So if I went back this way, where does that b go back to? It goes back as an exponent. Yep. So these two we're not really condensing or expanding. Okay, we're just kind of rewriting it in a different form. Okay. Okay, so we're going to go ahead and start with these two examples. We are going to practice expanding first. Okay. Right now, they are in condensed form because we only have one log and or natural log. Okay. What they want us to do is we want to expand these. Okay, so we're going to go from one term to however many terms that we need. Okay, so biggest thing with these when we start expanding, understand what's happening in our term there. How many terms do we have there? What I circled? We have two terms. What's happening between the two terms? Addition, multiplication, subtraction, or division. We're multiplying, right? How do we know they're multiplying? They're right next to each other, right? They're not split up by a sign and they're not written in fraction form. Right here, we know they're multiplying. So, what goes with multiplication when we expand this? We expand it with addition. So, we always keep that log base 5. Log base 5, what's my first term? A to the second. We can leave it like that for now. Okay? Plus, remember we keep that log, so log base 5. What's my second term? B to the 7th. We talked about how we can simplify this a little bit. What do I need to do before I'm done? What needs to be moved? Right. These exponents need to be moved. Where did we say those are moved to? To the front. Yep, they go to the front of their corresponding log. Okay, so 2 goes in front of the first log. 7 goes in front of its own log. Okay, so if I rewrote this, this is 2 log base 5 of A plus, what's the second one? 7 log base 5 of B. Now that's an expanded simplified form. That's it. So we went from condensed form to expanded form, and those mean the same thing. All right, looking at B, what do you notice?
It's division.
It's fraction, which means division. Good. How do I rewrite with division? It turns into subtraction, right? So just like multiplication turned into addition, division's going to turn into subtraction. So this is going to stay the same the whole time. So I start with natural log. What's my first term? 25. Yep, numerator. Natural log of 25 minus what? Right. Make sure with each term that we rewrite, we still have that log or natural log with it. Okay, so we have natural log of 25 minus natural log of 3. Is there anything else I need to do to simplify or rewrite that? Is there anything we have to put in front this time? No. Remember, what is going in the front? Like up here, what did we move to the front? The exponent, right? Is there an exponent in here? No. So we don't have to worry about taking anything to the front this time. So this is the expanded form.
You don't have to have an A and B.
I want to start off with B first. Okay. With B, again, understand what's happening in the parentheses here. What do we have?
Divide.
It's division. So when we rewrite, what are we going to use? Subtraction. Okay. You tell me, what do I write first?
Natural log 7.
Natural log is 7 minus
Natural log 2.
natural log of 225. Is there anything else I need to do there to simplify my writing?
No.
No. What about A? There's a lot going on, right? So again, we want to understand what's going on in the parentheses. Let's focus. What's the main thing that's happening? Right, you see that fraction, you automatically think division. But what do you see in the numerator? We have exponents. What else do we see? How many terms are in the numerator?
2.
We have 2 terms in the numerator. So I want to take care of that numerator first. Okay? We always keep this, right? Okay? So I'm going to start with log 7. What's my first term in the numerator? R to the 3rd. Okay, let's leave the exponent there for now. What's my second term there? How do I write the second term? Careful, what's happening between these two? Multiplication, so we add them together. Yep, so we do plus log 7 of t to the 4th. Okay. Now what's happening with the v? Then we subtract because that's what's being divided. But we got to be a little careful. Put this whole thing right here, that numerator, put that in parentheses. Okay. I'm going to ask you something. Can I do minus v? What do I need with v? I have to have the log base 7 with it. So log base 7 of v. Am I done? What do I have to do here? So I got to move the exponents to the front. Yep, so this 3 comes to the front. This 4 comes to the front. Does v have an exponent? No. And is it okay that v doesn't have an exponent? Yes. Okay, so this rewrites to what? You tell me. Good. Good.
Minus log.
Right, that one didn't change, right?
Sorry.
Now, is that an expanded form?
Yes.
Yes. Good job.
Okay.
So that example kind of threw all of the properties together. Okay. Biggest thing that we tend to forget about is those exponents, but you guys did a nice job of seeing those. Okay. All right. So on this, these examples now, instead of expanding, we are going to condense them. What do I mean by condense? We're going to make it smaller. So right now, how many different log terms do I have? I have 3 different log terms. We want to turn all of that into one log term. Okay, so what I'm going to ask here, what is my main log? Log base 4. Yep, so we have log base 4. Start your parentheses. Okay, let's take a look at that first term. First of all, notice these addition and subtraction. What do those mean? What is that going to turn into? It's going to turn into multiply and divide. So, do you agree we're multiplying the first 2 terms?
Yep.
Okay, what is my first term?
Log 4 and
Careful.
or
What does this turn back into?
m exponent.
That's going to go as an exponent again. So, this is going to turn into m to the 4th. What's the second term going to turn into? N to the 3rd. Yep, go backwards. Now we're going to divide. Do you agree because of that subtraction? Divide by what? Just p. Yep. And that's all you do. So we're going from expanded form back to condensed form. Let's look at b. What is my main log or natural log? What do I mean by that? What am I going to have out in front? Natural log. Remember, it's that ln. Yep, natural log. And start your parentheses. Here the base was 4. What is the base technically here? If there's nothing there. What did you say? It's e because it's that natural log. Good. So first term, again, we are going to end up dividing, right? So we're going to have a fraction bar in there. What is my first term going to turn into? Yep, because that becomes an exponent again. We have 2 to the 3rd over 5 to the 2nd. Now, just to make it a little nicer, let's simplify. What is 2 to the 3rd power? 2 times 2 is 4 times 2 is 8. What's 5 squared? 25. Okay, I want to clarify. What I want you to see first is what's happening between the terms. Okay, I want you to see that first, what's happening between the terms. Go ahead and try example 3, A and B. Let's look at A together. Again, we want to condense this to one logarithm. What is my main logarithm going to be in A?
Log 2.
Yep, we find their log that they have in common, so we have log base 2. What's happening between the 2 terms? What'd you say? Yep, we have this subtraction here, so we know that's going to turn into division, yeah? Okay, so how do I write my first term? Where'd you get the 5th from? Yeah, remember that number in front becomes an exponent, so this turns to c to the 5th. And then my bottom term turns into what? N to the 7th. Good. Okay, what about B? Natural log, good. What's the main operation happening?
Multiplication.
Yep, addition turns to multiplication. So how do I write my first term?
7 squared
Yep, that 2 becomes our exponent. So we have 7 squared
and 2.
times just 2, right? Can we make that a little nicer? This looks a little messy right now.
Can you put the 2 in the parentheses? I didn't put an X. Can you solve that?
Yeah, let's solve it. So if I have that natural log, what is 7 squared? 49, and then we have times 2. So we get natural log of 98. That just kind of cleans it up and makes it look a little nicer. All right, go ahead and write this off to the side for now. Log base 2 of 3. Okay, last week we solved this just by kind of guess and check. Okay, so remember this we're trying to find what this equals. So I'm going to represent that as x right now. What did we do to this to help us solve? We did the circle, right? So I start at where? Start at the base. Our base is 2. Now we circle. What's my exponent become? 2 to the x equals 3. Now, can you tell me an exponent that will make this true? How many times do I multiply 2 to get 3? Right. In our minds, we can't, right? If I take 2 times 2, that gives us 4. Well, can we get 3 from that? No. So this changing base formula is going to make it a lot easier for us to solve, okay? Real quick, I should have started with this example. Go ahead and write this example nearby. Log base 6 of 36. How do I rewrite this? What do I start with? 6 to the x equals 36. Now, can you tell me how many times I multiply 6 to get 36? Twice, right? So we know that this exponent is 2, because 6 times 6 is 36. Okay, but is it as easy for this one? No. So this is where this formula comes into play. We are going to take, I'm going to come below here. We are going to take log, I'm going to start with this example over here just to show you that it works. Log of 36 divided by log of 6. Yep. Because why can I do this in my calculator, but I can't do this in my calculator? Why can I do this in my calculator? What's the common log? What's the base on these right now? It's 10, right? Remember, if a base isn't there, it's base 10. So what we did was we took it from base 6 and we turned this into base 10 so that we can use our calculator. Okay, so go ahead, type log of 36 divided by log of 6. What'd you get? 2. So did it work?
Yes.
Yes. Go ahead and do the same thing on the other one. The other one's going to turn into what? Log of 3 over log of 2. You get x equals 0. Is that what you guys got? Oh, I'm glad we're checking this. Make sure you close your parentheses when you're typing it in.
Yeah.
Okay, so type log of 3, close your parentheses, divided by log of 2, close your parentheses. What'd you get? Someone got around 1.5? Cool. So make sure when you type this in your calculator, you're closing those parentheses. So now that we know how to solve these, remember, we're trying to figure out what this equals. So we used to represent this as we're trying to find what this equals. So with the changing the base formula, what do I write here? What goes on the top? Yep, log of 7 over log of 2. We can type that in our calculator, yes? So we get this to be what? 2.8. Does everyone agree? Okay, so 2.8 is our answer there. What about B? How do I rewrite that first? Yep, base goes on the bottom. So we have log of 3, our main term there, over log of 5. So base goes on the bottom.
Wait, that's not a little bit confusing.
What goes into that? 0.6. What was the second one? 6.8. Okay, so when we rewrite this, go ahead and write this formula on the front page. Add this to it. Okay, add this to the properties we talked about on the front. So if I write this as log base A of B, okay, this equals log of B over log of A. Yes, for this one. Yep, base is going to end up on the bottom. All right, so here I have 2x equals 7. Can I rewrite that into log form? Right now it's an exponential form. What's my base? Yep, so we have log base 2. And again, we can go in circle form here. So log base 2 of 7 equals x. Yep. And then how did we just learn how to solve this? We did the division, right? We did change the base. So we did log of 7 over log of 2. And this actually matches your 5a. And what did we end up getting for that? 2.8. Okay. So we can do the same thing with exponential form. Okay, so go ahead and try example 6 where it has 3 to the x equals 15. So we first want to write this into log form. Always start with the base. So I have log base 3, and then we circle. What's next? Log base 3 of 15 equals x. How do I solve for x here?
Log 15 over log 3.
Yep, log 15 over log 3. What did you guys end up getting for your solution? Say that a little louder. 0.405. We agree? Awesome. Number 4, we want to expand this. Right now I have it as 1 log. Understand what's happening in the parentheses. What do we got? Division, right? Because of that fraction bar. Dividing, what does that turn into? Subtraction. So remember, we keep this log base 6. So log base 6, what's first? The numerator. Log base 6 of 49. And then what do we say? Minus, what's next? Log base 6 of 5. Remember, when you expand, make sure that you have each term has that log base 6. Okay? What about number 5? We want to condense this time. Yep, we keep that natural log. Keep this here. So we have natural log. Yes, we have addition, right? What does that mean? It's going to go into multiplication. So what's my first term? Yep, where does that fifth come from? Yep, remember the number in front turns into an exponent. So we have natural log of s to the 5th. Careful. Where is this 6 at in regards to the log? It's in the front, so where does it go? It becomes an exponent. Yep, so it turns into t to the 6th. And remember, we were condensing that one, so we kept it all in 1 log. Okay? And addition turns into multiplication. Yep, that's why we're multiplying there. Okay. So both of these are in the correct form. This was expand. This was condense.